Right, hello. Got a little question here about some objects being thrown up in the air. So in this one, we've got a ball. It's thrown up from ground level and reaches a maximum height of 12 meters. How fast was the initial speed? So what I always think on these is you got to use your suvat equations. Write out suvat. S-U-V-A-T. And put down what we know before we start anything. So S is the distance. It reaches the maximum height of 12 meters. So S equals 12. U, that's the initial speed. That's actually what we're trying to find. So we need to know that. V, that's the speed that it'll be at the top. So at 12 meters, when it's 12 meters high, it'll have no speed, it'll have no velocity, it'll be momentarily at rest. So velocity equals 0. Acceleration, it's going to be gravity. Gravity is what's going to be, so it's 9.8, but I'm going to consider everything going up in my calculation. So gravity works down, so the acceleration due to gravity is going to be minus 9.8. The time, I'm not interested in. I'm not interested in the time on there. I'm not asked for it. So we'll go for these. So we've got S, U, V, and A. So we've got to use V squared equals U squared plus 2AS. So V squared is 0 equals U squared. And 2AS, well, it's going to be 2 times minus 9.8 times 12. So we're going to have 0 equals U squared, and this all works out to be minus 235.2. Take that over to the other side. 235.2 equals U squared. Square root it, and U is going to equal 15.3 meters per second. So that's that bit done. So it's straightforward. All you got to do is make sure you get your direction right. Let's have a look at a second one. We've got a ball that's dropped from a height of 18 meters. How fast is it traveling when it hits the ground? So again, I would write out suvat. S-U-V-A-T. S is 18 because this one is a little bit higher up. U, well, the initial speed, it's not given, but if it's dropped, the initial speed is 0. It's not thrown downwards, it's not thrown upwards, the initial speed is 0. Okay, so V, that's the speed it hits when the ground, it is when it hits the ground, so that's what we need to find. Acceleration. This time I'm working downwards. I'm going to be working on the idea of going downwards. So this time the acceleration due to gravity is actually positive. So it's 9.8. And T, again, not interested in. So again, we're going to use V squared equals U squared plus 2AS. So V squared equals, U squared is 0 squared, so that's not going to be anything, plus 2 times 9.8 times, and S is 18. So what does that come to? So I'm just going to multiply that out. That comes at 352.8. But that's V squared. So V is got to equal the square root of that. So V equals 18.7 meters per second. Okay, so we've got that done, and that's again, it's just working the other way around. And like I say, in the first one we could use acceleration due to gravity. We had it negative. This time I had it positive. It's just because of which way I'm thinking. I always think of where I'm starting from, the direction I'm moving. I'll make that positive. That'll be my initial idea. Now this time we're going to set these two balls off. We're going to do the same thing again. Put them on the same vertical line, and how high above the ground do they collide? So I'm going to draw a little diagram here because it's going to help. So it's going to be, say, 18 meters high. Now I've got one at the top, one at the bottom, and they're going to be going up. Now that one's going to be coming down, and somewhere or other they're going to meet. And I need to know how high they meet. So that distance is going to be S, but this distance is going to be 18 minus S. So that's the distances sorted out. I'm going to call this one A, because that's the first one we did in the first set of questions, and this one B. And let's have a look at A first. So let's have a look at A. Ooh. For A, what we're going to have, we're going to look at what we got. We got S, U, V, A, and T. So S in this case is S. That's what we're trying to find. I'm going to just call it S because that's ultimately what we're trying to find. U was what we worked out in the first question. We got 15.3. V doesn't matter. It's going to be traveling at some speed or hit the other ball. It doesn't matter. Not interested. A, I'm going to say is minus 9.8 because it's slowing it down. Acceleration is going to work against it. And time is what I want to find. Time is what I want to find. So S, U, A, and T, that's got to be S equals UT plus a half AT squared. So in this case equals 15.3 T minus half of 9.8 is 4.9. 4.9 T squared. Looks a bit awkward at the moment because we've got S equals, and we've got T and T squared. So we've got a bit of a quadratic there. It looks a bit awkward, but that will sort itself out later. So let's look at object B for ball B. And again, we'll do S, U, V, A, and T. And in this case, S is not equal to S, it's 18 minus S. U is 0, it was dropped to 0. V doesn't matter. A, I'm going to still consider this as positive. It doesn't matter because I'm just trying to find S, and I'm just going to use A as a positive, and T is what I want to find. Because when the two balls hit, they will have both been travelling for the same amount of time. So T is going to be T in both equations. So we're going to use this again. We've got S equals UT plus a half AT squared. So this time we've got 18 minus S equals, well, UT is 0. And we got half of AT squared, so we've got plus 4.9 T squared. Now I can rearrange this because I want to get S on its own. So if I make that, I'm going to have to add s to both sides, and I'm going to take away 4.9t squared from both sides. So I'm going to have 18 minus 4.9t squared equals s. Now I've got s equals to both of them, so what I can do is put them together. So 15.3t minus 4.9t squared equals 18 minus 4.9t squared. Well, if I add 4.9t squared to both sides, then both of them bits will go. So I'm left with 15.3t equals 18. So t is going to equal 18 over 15.3. So in this case, t is going to equal 1.18. So they will collide after 1.18 seconds. Now that's giving me the time that they collide. And the simple thing with simultaneous equations is we're just going to put that back into either of these two up here, and we can find out the distance. So we can put it into the first one. We've got s equals 15.3t. So that's 15.3 times 1.18 minus 4.9 times, how big is 9? There we go, 4.9 times 1.818 squared. And if you work that all out, that gets s equals 11.2 meters. So s would be 11.2 meters, and that seems okay. Yeah, it's just over halfway up, and that seems probably about right, because the bottom one's projected quite fast, the top one's just dropped. They're going to meet just over halfway. If I want to check it, I can check it in the other one, and that was just going to be that s equals 18 minus 4.9 times 1.18 squared, and that will also give s equals 11.2. So I can get it both ways, and that's what it is. And that's the thing with these sort of questions. You've got to break it down, do the two bits, get your two simultaneous equations, substitute into each other, and see what you get.